Okay, so today we're going to do something a little bit different, kind of an experiment. Um, in this course, I guess we have recitations and we have lectures. Um, and then today what we're going to have is we're going to have a workshop. I'm going to try this out as a technique. So in this workshop, what we're going to do is we're going to try to pretend like we actually have some work to do here and try to use some of the concepts of the course to get that work done. Um, uh, wait, I've got some. I have the. Yeah, I mean, I can mute people if I need to. So, the of course, the topic is going to be database design. So it's kind of, since it's so critical to kind of get the right definition of a database. But before I start, since recitation 4 has been released, or there's well, I hope it's kind of clear what the rest of the course looks like. I mean, we're going to have a lecture next Monday, and then next Thursday it's going to be recitation, and then the Thursday following that is going to be makeup recitation, and then the Monday following next Monday is going to be another lecture, and then finally we'll have a review and then the exam. But are there any questions right now, or anything that people want to see me explore, especially today? Like what are the part? What are if people want to just put it in the chat, you can make it even private, a private message. Just say things that you maybe want me to kind of touch on today during the workshop. Things that might not be that clear. Okay, so I'll just wait and see. But let's get started here with the workshop thing. This is a potato peeling problem. I was trying to peel a potato, but I peeled my finger. All right. The example of domain we're going to look at here is should be kind of familiar to everyone. It's this idea of we have students and their IDs. Okay, so there's a student ID, and then we have their names, of course, what they're majoring in, and I guess you can change your major. So just keep that in mind. I mean, I can major, for my first year. My first year, I can major in biology, and then I can switch to computer science. Or actually, in my case, what was it? I majored in history, then I majored in physics, and then I majored in computer science, with actually a brief majoring in architecture for one half of a term, and then back to computer science. So at least at the University of Michigan, we had to declare our majors. So those can change through time. So just keep in mind, this is a dynamic, this is changing through time. Okay, then we have course IDs, like the course ID here. Then we have traditionally it would be a room ID, but I'm kind of thinking that it's going to be a Zoom ID for maybe forever. I don't know. I mean, I'm kind of getting used to the whole purely computer world, Zoom everything. There are certain benefits, actually. Okay. Then we have a head teacher. Okay, so this actually, universities actually will enforce this. So you have a teacher that's the responsible teacher. You never want to share responsibility between the people. I mean, somebody has to answer for things. I mean, the buck has to stop with somebody. But then we can have assistant teachers. And in this example here, I mean, in our class here, we just have one assistant teacher, or amanuense, I guess. But let's consider these cases where you can have, multiple teachers on a course. But there can be more than one. There can be like 3 assistant teachers and 1 head teacher. So just keep that kind of in mind. That's kind of what we want to model that. Then we have the period. Okay, so at least in UMIA, we have VT and HT, and then the two digits for the year. Then we have the day. This is a particular, a day. There's a lot of these, but not that many really. I mean, how many days are there that in the recent past and the foreseeable future? It's limited. I mean, 365 times like 30 or 40, something like that. And then we have time. So this is like the time of the day. Well, actually, let's just be a little. We don't need to take it down to the second, but we will take it down to the minute. Okay. All right. So I hope that's clear, kind of what these attributes mean, right? And what we're going to try to model here is we're going to try to model like the assignments of students enrolling in courses, and students having majors, and teachers being assigned to courses, and then courses having meeting at certain times. So certain days, on certain days and certain times, they're going to meet in a particular Zoom meeting. Okay. So is that clear to everybody? Kind of what's going on? with that, I hope it is. All right. So the question is that we want to design a database that does this, right? So I think in the chat here, I suggested to everybody, just since we're going to be working with these right here, I suggested everybody kind of write these down on the side. I put them in the chat also, just because I'm going to move this and then we're going to kind of start working with just. I mean, we're not going to repeat these. This is crazy. We're going to use these kind of single letter abbreviations. Okay, so it's kind of important that everybody can quickly, when I say S, it's going to mean the student ID, right? Okay. All right, so let's take that to the side. So the issue is here now is that what are the, so I guess I'll just put it bluntly to you guys. What are the functional dependencies that hold over this? Okay, let's back off for a second. How do we want to design the database? I mean, and by the way, some people, maybe what you want to do, like just off to the side now on a paper, just say, what's all this theory that Michael's talking about? This is like pointless. I can just knock the definition of the schema out like with no problem. Okay, just kind of use your common sense. So we really have three different methods that we can start trying to do this with. We have the pure common sense. So we have method number one. I'll call that pure common sense. All right. It's like you say, I don't need theory. I don't need ER diagrams. I'm just going to use pure common sense to look at this stuff and to knock out some table definitions. And then with the primary keys and foreign keys and stuff like that. All right. So maybe in this example, common sense will be good enough. I mean, that you can just kind of knock out in the pure common sense way, you can do the definitions. I think probably this is the way it's mostly used in the world, that people just kind of like think about what they want to do. Then they just kind of start kind of tricking around with the definitions. And then they kind of try to get it, they get something that kind of approximates, or they get something that fits the domain, their understanding of it. Another way to do this is that we try to do this with ER. Okay, so we would have entities like students, we'd have an entity like a major, and then we would have, well, then it gets a little complicated because we have like, we have the entity of a period, all right, we have the entity of a day, we have the entity of time. We're going to look a little bit into how we might try to do this with ER, but ER might be it's not trivial actually how to do this with ER. And then finally, the third way is with normalization. Theory. Or better, maybe a better way to put it is with just functional dependencies. Okay. All right, what happens to functional? Okay, well, I had a question here. So, by the way, what I want people to do here, because I'm going to answer this question, which is good, because my hope was that what would happen is I would just introduce this, and then people, especially enterprising people, would go and they would just say, screw this, I'm going to do this right here, or I'm going to do this, or whatever. So I want people to start working on this right now. That's why we call it a workshop. I want people to start working on the definition of the tables with these attributes. These are going to be the attributes in the tables. And I want people to start kind of grinding out their own, on the side, their own definitions of what they think the table should be to represent things. Okay, is that clear? What I'm asking? Because I'm going to answer now another question. Because I guess it was a private question, but it looks like it'll be good that I can answer it. So this is the problem that we're working on right here. This is the main topic of the workshop. Is it clear what I'm asking here? For people to do. I'm waiting on the chat here to get some kind of feedback. Good. Okay. So that's a yes. So basically, I want people to kind of just like in the time I answer this other question, I want people to kind of knock out the table definitions, or try to knock out table definitions for this. Maybe common sense is good enough, and we don't need all this kind of fancy dancy theory stuff. Although we'll do the fancy dancy because this is actually still a fairly simple domain. All right. So now the question that I got. That's right. Yeah. Are we supposed to do it right now? And that is yes, absolutely. If not now, when? Just grind it out. Okay. So then, oh, sorry. Paper to the right. Did you mean this right here that I said, these are the three, you have three different methods you can use here if you want to do these definitions. Pure common sense, just grind it out. ER diagram, and then from the ER diagram, then hit a button on the ER diagram and knock out the table definitions, or do it purely with normalization theory with functional dependency statements, and then do the basically put it into BCNF or 3NF or 4NF or whatever, right? Okay, so that's I want people to start working with this, because this is the main topic. But now I got a more specific question, which I think I can work with a little bit here before. Okay, so this is a good question. So the question is that what happens if we have, let's say we have the functional dependencies, A goes to B, B goes to C, and C goes to A. These are our functional dependencies. So I'll make that right there to make it a functional dependency. That set. And now what we want to do is we want to compute F plus. Okay, F plus is F union something. So we'll just take this right here. So all these are going to, of course, be an F plus. Then we have A goes to B, B goes to C. Therefore, A goes to C is in that set. And then see, B goes to C, C goes to A. So B goes to A is also there, right? And these are the non-trivial, because of course we have A goes to A, B goes to B, etc. Well, let's see. Now if I go A goes to C, and then C goes to A, but that's just A goes to A. That's just a triviality. I think we're done. So we basically just do this to fix point. So we just use this, we use Armstrong's axioms to just calculate this to fix point. And since it's always going to be finite, there's always just going to be a finite number of potential functional dependencies. So it just finishes. So I hope that I answered that question. So that's the full closure in that case. Let's see. All right, so I think the issue is mostly is that I don't think you're going to be able to, in the time I'm giving you, and because it's kind of up now. If there's any other questions, I was just doing this just to kind of like have you guys kind of fiddle with the problem. You're not going to have the time to do all three methods, but we're going to kind of try to look and kind of explore all three methods as we work with it today. What I was just trying to get is for you to, first of all, at least write down the attributes that we're considering, these attributes, and to start thinking a little bit about how you do the table definitions. So, I mean, you're not going to be able to finish it before I get back to it, but at least you're going to be steeped in it, so that the discussion will be more productive. Okay. So now, I got a question. Okay. And by the way, this is kind of experimental. I mean, I don't know, this idea of doing a workshop. I really haven't taught this way before. Oh, C goes to B through A. Did I have? I'm sorry. It's a little bit flaky here. C goes to B. That's right. C goes to B, because C goes to A goes to B, and B goes to C. So actually be a transitive, but let's just do it this way. C goes to A is still there. Now we're doing it to fix point. So C goes to A, and A goes, I'm sorry. C. Which one did you want? You want the C goes to B. C goes to A, and A goes to B. Yeah, so that's right there, actually. C, it's one step. C goes to B. So, sorry, I missed one. Yeah. All right. So now we get back to this example here. And let's just start out, since normalization theory. Let's just start out with normalization theory. Could someone give me a functional dependency that holds over this, that holds over these sets of attributes? I just want let's just kick it off with this. I want to write down the functional dependencies that hold here. So if you go up in chat, we can see them all listed there. So could someone give me a functional dependency that should hold over this this domain? All right, so we got one right there. S goes to N and M. So when you're given the student, you're given the students ID, and you should be able to determine the name. That's definitely true. But what about the major? Like I said before, remember the major fluctuates through time. So like I said, I mean, I started out in history, then physics, then computer science, then architecture, then computer science. So if you just took the ID, the student ID, and then have it go to M, the major, that's not going to be correct, right? Because it has to be going through, it has to go through time. Not time, rather, but that's the question. What does it go through? I mean, but let's so we're looking at the student. We have the student goes to name. That's the name doesn't change. Okay. So could someone give me the functional dependency? How do we want to model this functional dependency where the student on a day-to-day basis, not on an hourly basis, but on a day-to-day basis, they can change their major. I mean, I think a lot of schools actually maybe they make you do it on a term basis. So every term you have to have a declared major. So we could do it that way as well. Maybe we want to do it that way. I don't know. I mean, Sweden's a little different. I think that you don't really get to declare, you don't get to change your majors around so much. But let's just do it by day to day. So let's say that on Monday, I can decide I want to be computer science. On Tuesday, I can turn into biology. And then I can come to my senses on Wednesday, go back to computer science. So how do we want to model that? All right, so then we have S goes to, we have another, S goes to, not quite, but you're getting the day and the major. You're bringing in the day and the major. That's good. But I don't think so. I think that if I give you a student, it looks like someone got it there. Yeah, so student and day goes to major. That's correct. That's right. Yeah. So student and day determine major. Okay. So if I give like student like with a certain ID, and then we talk about January 22nd, 2021, then we can determine a single major in that day, right? So the day is turning in. So this is basically becoming kind of a temporal dependency. It's based on time. Okay, are there any other functional dependencies that govern this? They govern the table or the domain. So you have the students, yeah, they. Let me just say one thing here. This is actually, I think, how they do it in the States. In Sweden, of course, this has been kind of a complete confusion for me. But generally, what happens is you can only enroll for, I mean, basically, a student can only enroll once for a course in a term. Okay. So on a particular term, now sometimes I think sometimes I get confused in Sweden with that because then they say, "Oh no, you got to register, again if you don't get everything done." But it looks like I have another one here. M goes to C. M goes to C is not going to work because basically there's going to be a lot of different courses. I mean, you could say something like this. I mean, and this is just a kind of let's not do this. So I'm just going to scratch it out after I do it. But you could say this: a major multi-determines a set of courses. That's true, actually. But I don't want to. I want to back off on that right now. But that's a multi-value dependency, so that would work. But you can't say a major determines a course because there's a lot of courses in a major. But let me scratch that out because I don't want us to get confused at this point. But I hope that people understood that was a multi-value dependency. Let's see. Just trying to keep up here. CH goes to Z. C is a course ID. Actually, you're right. If we really think about it, that's correct. Course, and then the head teacher. Not quite, not quite. CH goes to Z does not quite work because let's look at that. CH goes to Z. What's wrong with that? What's wrong with that is that I might actually. So C might be this database course, and H might be me, the head teacher. And I might change the Zoom course next year. I mean, I mean, let's assume that let's assume that the whole society is different now, and everybody's going to just forget about meeting physically because it's, the COVID is, hopping around, and maybe something else is going to hop around at one point. So we basically just say, screw it. We can all. It's a more efficient, easier life than just to do everything on Zoom. So we just make it a permanent Zoom culture. But the thing is, I might have a different Zoom ID next year. Just, God only knows why. But this is getting close. This is getting very close. Let's see. I see another one here. So I'm going to scratch that out because it's not quite working. Should I put this one in? Let's see. CH goes to A. That doesn't work either. What you need is the term. Okay, let's go back to this here. Okay, I'll write it down here. I'll help you guys out. The course, basically, let's put it this way. Forget it. You don't even need to have the head teacher. Although you could put the head teacher in there, it would still be true. And that's one of those things where we're going to look at. The course and the period, right? So this course in VT21, DV202 in VT21 determines a Zoom room. Okay. All right. Do we have any other ones that hold here? Any other functional dependencies that hold? So that's fine. This one looks reasonable. Okay, we have HD. But you guys, you understand why the P is period here. You understand why the P had to be brought in as well. So this is a different type. These are both kind of temporal. This is down to the day level, and this is down to the period level. So like the whole, spring and fall and summer, by the way. All right, so let me see, where are we at now? So C8, okay, HD goes to, yeah, actually, that HD goes to Z, that can also be expressed, right? But let's look at this, because that's an interesting one. That's an interesting one. But it's a proper observation, and I want us to kind of look at that a little bit. Okay, I have CP goes to H. That's definitely true. You got it right there. CP determines H. Very good. So the course and then the period it's given is going to determine who the head teacher is. That's absolutely right. All right, CP goes to H and goes to A as well. Not so much with A. So CP goes to, so I think that what I'll do is I'll just say that the next comment in the chat was CP goes to A, because it was CP goes to H. That's correct. That's the correct part. But it also had CP going to A. That actually is unfortunate. Well, that is actually fortunately not true, because we can have more than one assistant, right? But CP multi-determines A is definitely true. What that means is, it means with a course in a period, I determine a set of assistants. All right. So this is actually where multi-value dependencies, I mean, I know I kind of just like did multi-value dependencies, and it was like not very satisfying in lecture because I didn't really show, are they any use? I mean, what good are they? But this is actually showing why they're useful. Let me just put this at the top here, because this is what we want to look at. This one is going to be an issue. All right. So, but I hope that people see that. CP, so if you give me a course and you give me a period, there are going to be a set of assistants. Right? I mean, most people, when they lecture about, or they treat databases, most people stay away because this gets really hairy. This gets very complicated. And we'll see why this gets complicated later. But it really is useful to be able to say something like this, actually. Right. Do we have any other? So I was looking at this issue here, this HD goes to Z, and I wound up saying, yeah, I agree with that. I absolutely agree with that. That given like a head teacher, oh, wait a sec, actually, I don't agree with it. Sorry. I don't agree. Sorry. That was not true. Sorry. Now that I look at it, I don't agree. Because it says on a certain day, you have a certain head teacher and that determines the Zoom. But that's not true because a certain head teacher might have multiple Zooms on a particular day. So in other words, I might teach the database and the Java course or whatever, and they both happen to meet on the same day, and I have 2 different Zooms. So that would not be true. But I thought what I had kind of imagined, at least what was being said here, was more that I thought that it was course. So course on a day has a particular Zoom. Okay, what do I say? We truncate. CP goes to ZH. Let's be a little careful about truncating, or let's just kind of try to keep these things kind of simple. It's true that so there was an interesting question, a good question, basically saying, well, can we just kind of like consolidate these? I don't think truncate was the right way to say it, but can we just? So I'm getting a lot of private messages, which I think is great, because then people can freely. I mean, if you're worried about asking a question that's kind of like, you consider like an embarrassing question, something really basic, don't worry because one second. Don't worry because you can send it to me privately, and then I'll just yeah. I mean, and if you ask me, I mean, I want you to ask me like really obvious questions so I can so. But if you don't want to do it in front of your peers, then you can just send me a private. All right. All right. So let's back. Let's not do any consolidation yet. Let's just kind of look at this. So now I see something else. I see a CP goes to HA. One second. Let me just try to catch up here. Okay, I see this. I see that someone was saying course and D multi-determines a Zoom. All right, now that is true also. That is true, but it's true based on the kind of on what I would say is I'd say this: course and day determine a Zoom number, right? Because we're assigning just one Zoom ID to a particular course. So on any particular day, given that course, well, actually, that's the thing. Here's what was missing here. That is, and I'll just write it down because I don't want to like wait for someone to say it here. That D determines P. Is that true? If I give you a particular date, can you derive a period from that date? Like Höstterminen, Vårterminen, Höstterminen 19, Vårterminen 21. So VT shoot 21. So the answer is yes. So so if I take a date sometime in February of 2019, that's going to determine VT19, right? Am I right or am I right here? I'm right. Yeah, that's what it's going to do. So we have this idea that the day will determine the period. And then we also talked about this right here, that the course and the period will determine the Zoom ID. So therefore, actually, it's true then that just C and D will determine, because from day, I can then get period, and so then I have CP, and then CP goes to Z, right? So, but this is not really an efficient, this is kind of a redundant way of saying it, okay? So we actually want to, now, another thing also, since this holds, remember, if X, Y, then X, Y, okay? So this other thing of like, does CD multi-determine Z? Yes, because it functionally determines it, and therefore it multi-determines it. Because if it functionally determines it, then that's just a singleton set. And then, sorry about that. So look, if it singly determines it, so if I give you a course and I give you a day, right, then you should be able to determine what the Zoom ID is. That means it's like a singleton set. It's like a set of just one element. So therefore, it also multi-determines it, okay? So because it's multi-determining just a singleton set. So it's always the case that if X function determines Y, it also multi-determines Y. It's just that it's just kind of, it's not very satisfying because it's just a single, it's just a singleton set, but it still holds, right? But anyways, this is all just kind of a long ways. But the point about this right here is that when we're given this and this actually is a probably more succinct way of doing it, because this model is more kind of what we're after. That is, that the courses for a given period get assigned a Zoom ID. Now, if this was a room number instead, then we're back to something more like this, because rooms actually can change, as we all know. But that's another benefit of the whole Zoom culture, is that we don't have the whole complexity of booking rooms, right? Not to mention paying for them. Sorry. Okay. All right. So let's see. So let's kind of back off a little bit here. All right, so let's go back here. This is the goal that we've mined. So we've mined out these functional dependencies. Do we have any other functional dependencies that we want to model? Now I'll just do it because I just want to maybe speed this up a little bit. I'm going to say that student and one second. I got to get this right. All right, if I'd say that student, I got to think a little bit here. What I'm trying to model here is I'm trying to model that you can only enroll once in a course. So how do I do that? So a student, actually, I'm not sure if I can do that. We'll get to that a little bit later. So let's just kind of recall what we have here. Student name, students changing major, the course being assigned to Zoom in a certain period, the course being assigned a certain head teacher, the course being assigned a set of assistants, and then the day determining the period. All right. Yeah. Okay. What about if we want to model when all right. I mean, so we've gotten a little bit further here. So let's see. Does anybody have any other ideas of? Okay, yeah, we're not going to allow for the students to change their names, but if we did, then we would want to have the SD for. We want to have the day also enter into this functional dependency. All right, so let's think a little bit more about this. We want to have it. So how do we model the meeting times of a particular course? All right. Let's see here. So we have a. All right. So I told you this. Let's look at student enrollments now. So I told you right now what I want is I want students are only allowed to enroll once for a course in one term. Okay. So how do we model that? I'm saying I want to have it so that a student can only enroll once, in one term. So when they enroll in databases in VT19, that's the only enrollment they ever have will ever have for databases. All right, looks at this. Course period multi-determines the T. All right, so the multi-determines, you can do a lot with multi-determination, but the thing is that we got to be a little careful about doing too much with just practice would say that we can maybe, if we can do it with a functional dependency, let's do it with a functional dependency rather than trying to get it to work with multi-value dependencies. Multi-value dependencies are kind of weaker statements in a way. So it's we want to go right to the. So like I said, if given what I want is I want to basically say given a student and given a okay, we'll see. Sorry, given a student. All right, so that doesn't. I see that there were some ideas there that they're not really quite working. So, I mean, this is kind of at one point you get the hang of how to do this. But here, let me just write down what I had in mind. Given a student, right, and given a course, What does that determine? That's right, period. Gosh, I need to cut my nails. Sorry, I was going to do that earlier. Okay, student and a course determines the period in which they're taking the course. People see that? All right, so now we want to go to a little bit. So if let's just kind of cut it off at this, because I don't want to get too much into. Let's see here, or should we? Should we go the whole way? What's time? We have another thing we could model, and let's just see if we can get it done here. And that is to say that that, for instance, a course that at a given time, there can only at a given time, a head teacher can only be let's see, or we could say this. We could say another thing. We could say that for a given, can we model it this way maybe? Well, we can try. Let's just try modeling it this way. For a given Zoom ID, we can only have one. Okay, for here, I'll just make this one here. For a given Zoom ID and a given day and time, right? So for a given Zoom ID on a particular day, in the 20th or 21st or 22nd century, and at a particular time of that day, we can only have one course. Is that true? I think it's true, right? Is it true? I mean, do people understand why this would be true? No, Z goes to C is not true, because maybe I get the Zoom ID. No, that wouldn't be true. But maybe we think about it. I mean, let's just assume that the Zoom IDs can be shared. I mean, you can use the same Zoom ID later on for a different course. But anyways, Z. So in other words, the Zoom ID this year might be different than. I might use the same Zoom ID this term. I might use the Zoom ID I'm using this term for Python next term, which actually I think I will. So, just to make it so in that case, Z would not determine C. Just to kind of like fiddle with a little bit here, we could also say this: a course at a given date and time also determines the Zoom ID. Sorry. Yeah. Right. Because if I have a course and a certain day and certain time, then I'll get a Zoom ID. Now, I think what might be confusing sometimes is that there'll be a lot of emptiness here, right? So, there's how many days and how many times are there? I mean, there's so many. But the point is, if you pick two of them, do they have to agree on the same Zoom ID? And the answer is yes. Just think about it. I mean, I can't have a course on a particular day at a particular time, two tuples for that, and for one specific course, and have them have two separate Zoom IDs, right? That makes no sense, right? Okay, let's leave it at that. Let's just kind of like take these guys right here. All right, and let's just kind of we may not. I mean, I'm not sure if we're done yet. There might be other stuff we want to model. So, for instance, we might even want to model something like saying that a student cannot a student's if there is a student and there is a so I could have this S here. If there's a student and there's a day and time, I want them to be that to determine a course. What does that say actually? If I say that, what it says is I am not going to allow students to enroll in courses that meet at the same time. People see that? If I say SDT determines C, that means that I want it so that if I get any student and I get a particular day and a particular time, there better be one and only one course that they're attending. Now, do I think that they should have a table that enforces that? not really. I mean, so this is where common sense comes in too. I mean, we could do it that way, and the students would then say, well, why can't I enroll in this course? And then they'd say, well, because the system says another course meets at that same time. And the student kind of rolls their eyes and says, oh God, just over regulation. Let me handle it, okay? Another advantage of the Zoom era is that things are recorded so you can look at them later, right? Okay. So anyway, but I hope that people get a sense of kind of what kind of how the thought process that kind of goes in to kind of playing around with these kind of things. I hope that's kind of the point of the workshop, is to kind of give people kind of a sense. I mean, just kind of winging it here and seeing kind of what falls out of this. All right, but let's just say now we're done with the. Let's say now we're done. We'll see what plops out of this whole thing. But now we're going to say we're done with the with the specification of multi-value dependencies and the functional dependencies. All right. Okay, so let's just quickly do this another way, just to kind of make things kind of interesting. All right, I'm going to do this rapidly in like 4 minutes, and this is gonna really suck, but let's go for it. Student. Okay, got student. I got a course. I got a head teacher. All right, and I got assistants. All right, and what else do I have? Anybody help? Major? Let's major. Okay, fine. Student major. All right, and then what else do we have? Teacher period. Okay, then we got this thing period here. We got a period. And then we actually have a day. And then we have, as a separate thing, we have a time. So it's like the time of day. Am I right? Let's see. So we got the time, the period, the day, the major, the student, the course, the head teacher, the assistants, the day. Okay, I think that might do it, maybe. Oh, the Zoom ID, of course. Where am I put that? I gotta think. Ah. Okay, now I hope everything fits. All right, so the Zoom room, the Zoom ID. Okay, so, okay, now what are we gonna do? Now we're gonna basically start saying, okay, a student enrolls, okay? A student enrolls in a course on a period. All right, so this is kind of a little bit of a funky way of making it so that these are all, so these right here winds up being the, what are they? Yeah, the cardinality is a little bit funny on this thing because how we're going to, or the multiplicity is a little bit funny how we read off multiplicity, but basically student and periods map to many, so many student period map to a single course. So it's many to one rather. So let's just continue though. Head teacher, teaches. All right, I know this is getting a little bit, teaches. All right. Assistants, okay, now this right here is also going to bring in the period. And now, though, it's a little bit, this is, okay, head teacher. Now this is not even quite right. Let's just wait on this for a second. The head teacher teaches a course. Head teacher teaches a single course. Head teacher, now that's not going to be quite right. We've got a little bit of an issue here because you can have a head teacher being assigned multiple courses. I mean, as a head teacher, I can be assigned in a given period, I can be assigned more than one course. So we don't want to have it so that, that way. So how are we going to deal with that? I think we just keep this, the thing, we don't want many to many. So we have a little bit of an issue here about how we're going to specify this in the ER diagram to really capture what we want. Let's see. Anyways, I hope people can see this is going to, if you thought this was, if you thought this was kind of a painful process, right, to kind of get this all right. Then this right here is also going to be, it's going to be fairly involved here because we're going to have, because period is involved, is all these relationships are becoming temporal because we have these kind of temporal entities that are now participating. So we don't really have any of these kind of old fashioned, just, you just have, everything has more than, all of these relationships are beyond binary now. They're trinary or quaternary. We're going to see that they're going to, well, I'm not sure about quaternary, but they're at least trinary because we're bringing in the time, the temporal elements, or temporal entities rather. So things are going to get complicated, and I still have to kind of work out how we're going to get this here to get the right mapping. That sure, for a period and a head teacher should determine a course. Well, rather, it should not be the case that a course can have more than one head teacher, because we don't want to have this thing to be many to many. We somehow have to make it. So it may be that just by using the arrow notation, we can't really specify exactly what we want. And to really formalize it, we would have had to put it into functional dependencies. But maybe formalization is kind of overrated, and maybe you guys just kind of grinding it out with your common sense are going to be able to get a good design. But we'll see in the next hour. So now we'll just take our break and be back at 11:15, and put any questions in the chat, and I'll try to get to those. So okay, so let's take our break now. Okay, just a quick point for people. The time edit had it wrong about lecture being this afternoon. It's class will be holding the lab Redovisting period, meetings or whatever this afternoon. All right, so let's get back to this. Unless there's any other direct questions. Let's look. I just want us to kind of look at this right here again. So yeah, so this is how do we want to do this? So basically, here's my question. I want to set this up as a multiple choice for people. Do we want to put the arrow here, A, B, or at C? Which one do we want? Where do we? Because again, we want to model the fact that given a particular course in a particular period, then we assign one and only one head teacher. So where should the arrow head be? Yes, exactly, A. So it should be right here. And I guess strictly speaking, it should be rounded. All right, so it gets a little complicated when we talk about arrows that are coming off of these things. I mean, what is the meaning of this? I mean, I guess you could probably kind of assign a meaning. And then, so we have 3 entities coming in, and then we have 2 entities being determined. So there are limits to kind of how far this probably can go. I don't know. This is hard to kind of imagine what the meaning of that is. Anyways, this solves this little problem I was like trying to deal with right here. So I basically put this in here like that. And then with assistance, period, assistant, and course. And I believe this just maintains itself as a peer many to many, right? Because you could have many assistants. Over the years, assistants can, your money assistants can be assigned to there's really no restriction on it's a full many to many among all the participating entities. All right. So, anyways, we're not going to pursue this much further here. But the idea here is that, it's getting a little bit complicated now. When you press a button on this thing, and then you plop it out to Zoom ID, and the student has an ID and a name. We haven't even, this right here involves a term as well. Okay, student, nope, sorry, that was a day. Student day determines a major. Then we had the whole issue of when the Zoom meetings are meeting. Anyways, you get the idea. It's going to be a pretty, it's going to be a pretty messy diagram here, but you could continue with this and then get it to a point where I think you'd probably get to a point where you'd be fairly happy, and then you could make it so it gets pounded out to relations. If we get the time, we'll come back to this and see what that would look like. But let's go back to our more normalization theory orientation for today's lecture. So by the way, has anybody just gone and ground out the table definitions? Like using common sense? Has anybody done? I mean, it's no big deal if you haven't, but I'm just curious if anybody has. If you have, you can send it. Just send it as a private message, maybe, or as a public. I mean, you can put it in the chat. Just go ahead and do that if you want. All right. So, anyways, we're back to this right here. Let's just start out with we have the full relation. We're gonna do 4NF to start out with. In fact, I think there's a lot. I'm not sure if we're even gonna do a 3NF because it's a little bit of a complexity with. I'll talk about that in a sec. Okay, so we have R is S, N, M, C, Z, H, A, P, D, T. Should be 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 10. Here it is. This is going to be the normalization. I'm not going to do the pure common sense. I mean, we're going to apply common sense to what plops out of this. So common sense will enter in, I'm afraid. I mean, the goal, of course, is that we don't have common sense entering in and everything's kind of guided by theory, but that's fairly ambitious. I think it was mentioned at one point that somebody said, why don't you just do this? CP determines HZ, because it determines that. So I'll do that. It might, just to get a little more beefier, to have a little more beefier rules. Can I consolidate anything else? No. Anyways, I'm not going to ask people because it's kind of a painful calculation. A computer could do it, but it's painful for us. I mean, that is, I can ask you what a super key is for this, but for me to ask you what a candidate key is, it's probably going to be, anyways, it's pretty clear that this thing, that a lot of these functional dependencies is S, this will start out this, is S a super key of this relation? S goes to N, no, it isn't. Okay, so I think all of these rules here, all these functional dependencies are violating BCNF already, okay? This one up here, if you can see that's a multi-value dependency. And then the question is this violating fourth normal form? Okay, so if you recall, what fourth normal form says is if you have a multi-value dependency and it's non-trivial, and this one is non-trivial. I mean, this one doesn't just come out as a triviality. All right, if it's a non-trivial multi-value functional dependency, for it to be in 4NF, CP has to be a superkey. Is CP a superkey of this relation? With CP, can I get everything else? I'm waiting on chat. Is CP a superkey of this relation, given these functional dependencies? Good, yeah, I got it. No, it isn't, of course not. So the very first step, and generally speaking, when you have these kind of things, I think the first thing you want to do is to apply as just a heuristic, you want to do the multi-value dependencies first. So what's this going to give us? This is going to give us is the following. It's going to give us R, just like the other one, and then all of this minus A. So we're going to get, what are we going to get here? We're going to get R, I'll call R prime, S, N, M, C, Z, H, P, D, T. All right, now if we go to this one right here, is this guy right here, is this relative to these functional dependencies? Now we're basically done with this now. We're done with this one. This one's kind of dealt with, so we don't have to worry about him anymore. Now, the question is this in BCNF? All right, which of the functional dependencies here, or in a closure of these, which one of these have a happy home inside of here? I don't think any of them do they? C and P. So course and period determines assistant. Course. I think that there's nothing that applies here. So none of these have a happy home inside this right here. So technically speaking, this isn't BCNF. Okay. So we're done with this one. This will be one of our tables. This will be one of our tables. All right. Now let's go to this one right here. Now, let's just see. What do we want to do? What do we want to pull off here? It's easy for us to pull off S goes to N. Okay, is S a super key of this? No, absolutely not. So let's just pull off S. S goes to N. So we have R, S, N. Okay, and then we have R double prime, student, N, C, Z, H, P, D, T. Uh-oh. Okay, so far so good? Okay, good. So now we've dealt with the student name. So it looks like this. Now, what about the major stuff? Why don't we get the major dealt with as well? So S, D, and then M. Okay, so that, and then our triple prime is going to be S, C, Z, H, P, D, T. All right. So now we have three tables. We have one table that right there looks like it's going to be the course and the period, and then the assistants that are involved. Course and period and assistants, and there's no keys. There's no functional dependencies that apply to this. So it could be any in any combination. Right. This is giving us that full many to many. This right here is going to be actually the key is going to be student name, student ID here. So that's our second table. Our third table is going to be student and day is going to be the key. So student and the student ID and the day is going to determine the major. All right, so that's getting us the kind of the full temporal dependency there. All right, now let's get to this right here. Okay, now things might get a little tricky here if we're not careful. It looks like, now I'm going to use some common sense because I don't want this thing to screw up. So it looks like if day determines period, that would be problematic. We don't want to, we basically, let's use our minds here. The question is, we don't want to lose any of these dependencies. Okay, should the R to the left only be R? Should R to the left? I'm not sure if, oh, okay, good. I guess I answered. All right. Course and period determine the Zoom and the head teacher. I think this is a good one for us to pluck out at this point. Just common sense tells me this is the one we should go after. So that being said, that will give us R4 and CP, which will be the key, HZ. And then that will then give us the R quadruple prime. And then we get to get rid of H and Z. So that will give us S, C, and then PDT. All right, that's kind of getting a little bit hard to read. Okay. I'm going to move that over here. I'm going to copy this guy over here. Okay, so R, 1, 2, 3, 4 prime, S, C, P, D, T. All right, so what are, and of course, all these right here, this guy right here, we didn't even check here, but let's see, does he, yeah, it looks like he's fine in terms of BCNF. It looks that way. Now the kid's going nuts again upstairs. All right, anyways, okay, now, student course. I say now intuition tells me it's good for us to pull off this guy, the student course. See, if we did this one right here now instead, then we would lose this dependency because P would fall out of here, all right? And then we would never get, so what we're trying to do here is we're trying to make it so it's going to preserve all the dependencies. So using common sense, I'm going to say, let's go with this one here. Student and course determines period. So that would mean R5, student, course, period. Okay, and that would be the key of that. Now that means we can get rid of p here. So now I'm going to say r5 prime, and then that's going to be that's a v for Roman 5. Then that's going to be we're going to get rid of the p here. So that's going to, is that right? Yeah, we're going to have s c d t. Okay. Now, what do we have after that? Now, all right. So now, it looks like we've lost these guys, I'm afraid. But we're trying to get to BCNF, so we just, you know, the way it goes. Let's go D goes to P here. Let's get rid of that. Let's just at least get the day. We got at least this one here, because is D a super key of this? No, so we know we can break that off at least. So R6, and then we're going to have DT. Right. R6 DT, day determines term, and then we're going to then get R6 prime is going to then be SCD. SCD. Student course D. Yeah. All right. D for day. This is kind of a curious relation. But anyways, this is so okay now. So the thing is that this now we're done now. By the way, I'm almost certain we're done here. That these are all in BCNF. So all of these can be done in BCNF here. So what do we have? We have R1, and I'll just basically say, what does this correspond to? This corresponds to basically the course, the period, and the assistant. So this is like the assistant assignment. So I mean, we should have an intuition about what that means. It's like the information about the assistants. This one right here, this is the information of the students and their names. Okay. R3 right here, this is the students and one second. What was M again? Oh yeah. This is the temporal notion of the majors and how the students change their majors at any time they want through the days. This right here is the fact that a course in a period has a head teacher and a Zoom ID. All right, so this is all grouped together in that one table there. This right here is basically saying that for a given student and a course that they only take it in one period. They only have one time they enroll for it. This right here basically just says, okay, for given a day, this is the term that it is a member of. Now you might say, would we ever make this a table? Would we ever actually have a table that would have like all the days listed and then the term they're in? I mean, that feels kind of wasteful, right? In a way. I mean, don't we have a definition that, you know, vorterminen starts on a particular day and ends on another day? So why don't we just have that as a rule somehow? And I mean, I'm a database weenie, and basically a database weenie says, no, please, no rules, data. So actually I like this. I like just grinding it out and having a giant table with every single day listed with a term. People call me stupid, fine, I don't care. But the point is, it's nice. Oh, you're right, that's time. Oh, that's worse. Let's see, where did P go to? Uh-oh. Did P dropped out here? S. Uh-oh. Yeah, we got a problem here. We got a real problem here. Day does not determine time at all. This is kind of a, all right. So good point that someone made. This is kind of a this right here is kind of a degenerate relation here. There's no key here, by the way. This is just a degenerate. This is, we would not want to kind of grind this out with a date. This is kind of pointless. So we actually do have a degenerate. We have some degeneration in the, you know, in the actual, but it's in BCNF for what it's worth. But it's a degenerate relation. This one here makes sense in the sense that it's the student and the course on a particular day. Is that right? Student, course on a particular day, which is kind of a little bit degenerate because it should be P here. So I guess the point is that this is a BCNF decomposition based on the functional dependencies we had. All right. Is it a good one? No. All right. Now, if we do the other way, what's our other option in terms of doing the decomposition? We have another option, and that is it's called 3NF, right? So 3NF is going to be complicated. 3NF, our 3NF algorithm is going to be somewhat complicated by the presence of this multi-value dependency. But let's just try our best to see that. Well, let's just ignore that for the time being and see what we get when we try to grind this out. If we do this, then of course, to do 3NF, we have to go take this back here to Z. Okay, and what we're going to have to do then is we're going to basically say, what is it going to give us? Well, this is very trivial what it gives. So these are all the functional dependencies we have. Are these functional dependencies? Have we removed all the redundancy in these functional dependencies? That, of course, is going to survive. That's going to survive. These two are going to probably survive. CP, yeah, looks like they will. D, this will survive. That should survive as well. This right here is where the complexity might be. Z, D, T, C, C, CP goes to Z. So let's see. Can I using all these, can I derive this one right here, this guy right here? So let's see, what's the best way to do that? The best way to do that would be to start out with like, if I start out with CP goes to H, and then P goes to nothing. That give us a zoom. 1 second here. Yeah, look at this. Day, here we are. C, CP goes to Z. If CP goes to Z, then so does D. D. Those all go to Z because I'm just enriching the left-hand side. I'm augmenting the left-hand side. I could augment the right-hand side as well, but then I could just drop them away. So T, D, C. Okay, then we got period. Goes to Z. Okay, and CP goes to, let's see, I already did. Okay. Can anybody help me out here? Can I get this? I feels like there's a redundancy here. I mean, there is a redundancy here in the following sense. That is that actually, let's just let it be for the time being. I don't think we need to actually deal with it right now. So, but I think I've got a feeling I could derive a redundancy there, but it's not necessary because we'll see what happens when we grind this thing out. All right, here we are. Nope, not that one. Here. Free paper. All right, so let's say hypothetically right now, let's just say that we've looked at it and we think, okay, these are something really kind of silly is going to happen here. But I'm showing you kind of how this happens. And yeah. Let's see here. Let's bring this guy back here. So we're going to still consider him. So then the question is this: is that what we're going to do is we're going to group all the left-hand sides. CP, not quite. No, this is causing a complication in 3NF. I mean, they don't really discuss how 3NF deals with MVP, multi-value dependencies, MVD. So let's just focus on these guys first, and let's just kind of do this. Okay, so R is going to be S. So we're going to group them. So we're grouping the left-hand sides. So these guys are going to group, but otherwise there's no groups. Those are just the ones. Okay, so we have, falling out of this one here, we have SN. That's just the student name table. And then we have student day major table. Then we have the, just like we had in the VCNF, we have the CP HZ table because we've grouped both of those sides. And then we have the day to period table. This is the table I was talking about where it's good just to, I mean, it's as a database weenie, I just like to have these completely ground out because it's not that much data really. I mean, it's not, I mean, you know, and the nice thing about that, I just want to make a side point about that. You see, people see the point where like there's like this temptation to say, oh, well, the mapping from days to periods should just be done as a function or something. Yeah, maybe. But the thing is that it's kind of nice to sometimes have things just filled out as data because then you can just kind of deal with it in a uniform way. You don't need to complicate your SQL. And also if there's some strange exception, right? If there's some strange exception, you can go and you can edit the data and put the exception in. Anyways, so let's see here. All right, okay. So where was I? D goes to, okay. Then we have the R SCP here. So student course period. So this is the one that determines the that you can only enroll in a course once. Maybe you get your grade later though. That's kind of actually, I would prefer us to do it this way, but we don't apparently. All right, now let's get to this right here. So that was that. Now, if we get to this one right here, it's strictly speaking, if these two are separate, well, look what we're going to get. We're going to get ZDTC, and we're going to get CDTZ. Okay, look, these are the same table, CTDZ. So basically, what kind of idiot's going to declare the same table over again with the same attributes? And by the way, just when you're doing 3NF, if you somehow out of this, you got something like a table that was like a subset, or let's say that out of this, we got the table S or something. Let's just say we got that. The point is that this, sorry, I didn't mean to say it that way. Okay, if we got this right here, then we could get rid of this one because this is all contained. Whatever information is in here is going to be contained in here. Okay, but we don't have that one, thank God. All right, so just looking at the functional dependencies, this is what falls out of 3NF. Okay, now if you recall, like the last step of 3NF says, do any of these contain a candidate key? Do any of these relations contain a candidate key? And if not, we need to have a relation that has the full candidate key. I don't know. I think, do any of these contain the full candidate key? I don't believe so. So there's this other kind of, and it's probably going to be a degenerate. There's some degenerate relation that's going to also be included. But once we work with a little bit, I think we're going to determine that is degenerate. So common sense will let us get rid of that, whatever that thing winds up being. So did anybody ever calculate what a candidate key of this is? We know that A is in the candidate key. And then what else is in the candidate? We can do it here. What's the candidate key of this full relation here? We know A has to be there because A is not on the right-hand side of anything, or left-hand side rather, either. Okay, so it looks like S has to be in there. And it looks like a day has to be in there. All right, now if I have ASD, then what else do I need? Course, it looks like course has to be in there. So let's see, if I get a course and a D. So with that, with course and day, we can get, I think this might actually be a candidate key. Is that right? Is that a candidate key? Well, from all this, we can certainly get N and M. And then what we can also get CP, we can also get P, right? Because day determines P. And then from that, we can get H and Z, right? And then SC goes, okay. And then we can get, so what is that now? 1, 2, 3, 4, 5. We have one more to get. Well, is there any other one there? N and P. What's the last one I'm missing here, guys? Course. There's another student, name, major, course, Zoom, head, assistant, name, period, day, time. Yeah, time. Oh, yeah, looks like time has to be here as well. Yeah, so this right here, strictly speaking, if we do 3NF, we've got to shove in this guy A, S, D, T, C. Okay, and that's this looks like this is degenerate. I mean, we don't want to have that table. But let's just get to it here, and let's just say let's finally CP's period. Anyways, common sense again. I want to represent this, so I'm just going to put just as a common sense thing. I'm just going to bring in our CPA. Okay, so I would basically say then that the intuitive, this right here, how do I prove this is degenerate and not necessary? I'm not sure. Let's just hold off on that for a second. I say that the way we want this thing to work is we want to have R1, 2, 3, 4, 5, 6, 7. So what's good about this right here? Okay, number one, by the way, guys, this can be the key there, and then Z dt is the key. Sorry, that's the key, and then let me just say that CTD. That's unique. I make that unique. Okay. So yeah. So there and then there and then there and then there, and then no key here. Okay. All right. So I'm mixing 3 and F. So 3 and F is good in the following sense: is that do we know by definition that all these function dependencies that we came up with, are they being respected in this decomposition? Yes, by definition. So we don't have the problem that we had with, let me see if I can grab it here. With this, what do I have? Well, you recall we had the BCNF decomposition, which had lots of strangeness in it. And also, more importantly, did not capture all of the dependencies, right? So it was not dependency preserving, which was a problem. So, so we know we're going to preserve all the dependencies, at least with the 3 and F decomposition here. We did a little bit of hand waving here to kind of bring over the multi-value dependency to get multiple assistants. But since we don't have any real direction, the algorithm is not giving us any direction really on how we apply multi-value dependencies in 3 and F. So I just kind of brought it over on the side as a common sense move. But I think this is probably a pretty, now this right here, we still have to kind of look at this. And now when you look at this thing right here, you might say, all right, so here's a question. Why do we do R double? No, in the BCNF decomposition that we had, where is that thing? It was a big, I can't find it now. Or, yeah, I can find it. Here it is. It's just looking at me. Remember this BCNF decomposition here, when we just kind of ground it down using these guys right here, just to kind of grind. The first thing I did is I just applied this guy up front, which was kind of nice, just to kind of get the 4 and F taken care of. But when we were just doing this, we're going down here. All these are intermediaries. The R, R prime, R double prime, all the way up to R6 prime. Those are all just intermediate as we're doing the work. The things that are on the leaves, well, I guess this one isn't. So the last R prime is not. The things on the leaves, those are what we harvest to actually get the decomposition. Okay, we actually get those become the table definitions, right? So that, just to answer that question. So the R prime, those do not become tables in this thing. This thing, of course, went kind of pear-shaped. It kind of got sloppy-doppy at the end here. The question might be is that if we had, if we had a program that was doing this, because maybe that would make it a lot easier, maybe, rather than having Michael kind of scratch it out. We have, after doing the first one here in 4 and F, we have 1, 2, 3, 4, 5, 6, 7 possibilities. So we have basically 7 factorial different trees that could potentially be. We have 7. Well, sometimes some of these might not apply, but we're on the order of 7 factorial different combinations. So maybe one of the combinations of all those is the one that gives us something equivalent to to this, maybe, which preserves all the dependencies and is otherwise spectacular. And then what would be nice about that is then we would be guaranteed that it was lossless, right? So that when we rejoin it, it all fits back, it all kind of resynthesizes. Now, this guy right here with this, okay, so we followed three, you know, aside from this little kind of hand waving I did about the multi-value dependency, aside from that, we've pretty much followed 3NF to the T, but then we determined that there was no relation here that had a candidate key. So we also have to have this kind of, we also have to declare this relation here, which is the candidate key relation. And now the issue, of course, is that like, well, this thing looks pretty, you know, when I have this relation here also that I put to the side as a hand waver, but this relation here kind of looks kind of degenerate. Kind of looks like that's like just a bunch of junk that got kind of put in there. So then the question is, why did we do that? Why did the 3NF algorithm make us do that? What's the reason? Anybody want to say? Well, the reason is because remember this property that we need to have of losslessness, right? So the idea is that if I take all these guys, so if I need to take, sorry, I'll just do this kind of straight. If I take R1 natural join out to R6, this right here was my hand waver, so I'll just kind of skip that guy for now. Natural join with this, I'll call this RP for R prime. Or I'll call this R sub D for R degenerate. I'm sorry, not a sub. Yeah. R sub D for what I think, or what I'm calling degenerate. Of course, it's not degenerate in the sense that it has A in it, which it's just needed. But this has A in it as well. The issue is that this whole thing right here, the theory tells us that this equals R, okay? Which is really good about 3, because this thing is the candidate key here. So this is the reason why we need this guy right here. Because if we didn't have this guy, we don't have a guarantee. Well, we know that this will not equal R because there's no A mentioned here. But if I say this, natural join in R7, this is this guy I hand waved in, does that equal R? And the issue here is the equal. I mean, the reason why I said the kind of the logical equal, I don't know if you guys can see, that's like 3, 1, 2, 3. Because this has to work over any possible states of these database tables. It can't be over any one particular state. It has to be over any of the infinite number of states these tables can assume, right? So this right here becomes then a question. Now, because I want to get rid of this thing. I don't like this. It looks pretty junky to me. I'm calling it degenerate. I don't like it, but maybe I need it. But if I did this right here, and I had automated tools, of course, there's an algorithm I can use to see whether or not this is lossless, and that would be the Chase algorithm. Okay, that would be the Chase algorithm. So again, okay, so if you're going to work with this stuff, I mean, so I guess what I'm trying to say with this whole workshop presentation today was just to kind of show that it gets a little bit, common sense is always coming in a bit, but the tools are also there. So we have the kind of the basis of these algorithms. And if we had these implemented, we can actually do this quickly and have maybe some automated tools that would help us out doing that. I want to say which one last thing here, and then I just want to make one final comment after that. That's kind of a bit kind of off to the side, but kind of maybe says another thing about normalization theory. Anyways, if we go through this, process here, we're probably going to be able to do it, but it's going to be a messy diagram. But I think we're going to be able to do it. We're going to wind up getting, so this right here, this enrolls, student period enrolls right here. What this is going to wind up giving us is it's going to give us the student ID here, which is A. Or, I'm sorry, not A. Is S. That's S. The period is, of course, P. and C, the course ID is C. So what this thing is, this is a many-to-many. I mean, well, it's, let's see, how am I going to say this? It's not, it's the fact that you have two of these participating means that it's going to turn, this right here is going to turn into, let's put it this way. If you follow it this way, this is many-to-many. Many periods, a student is enrolled in many periods, and many periods have, many periods have a student enrolled, right? A student, there are many students enrolled in a period, and there are many periods in which a student is enrolled, right? So if you go this on this direction of it, sorry, if you go, let me see that a little clearer. If you go on just this part of it, you just visit this leg of it, it's many-to-many. Therefore, this guy right here is going to wind up being a table, and that table is going to wind up being, of course, R, and then you just kind of bring in the keys here. That's a key, that's a key, and so it's going to be R, S, student period, course. And then the idea or the fact that that's a key right there doesn't really come from our button pushing algorithm, but it's in there. You can kind of see that it's in there. So again, automated tools could potentially be able to respect that. I'm not sure if Irwin does that kind of stuff, but maybe. And then this right here, this table right here, that's just, sorry, you won't have to be careful with this finger. Sorry, I mean this finger. This right here, that table right there corresponds to, of course, one of our SPC. It corresponds S course. Sorry, I had this wrong here. This student and period determines the course. Student and course determines the period. That's true too, right? Student and course determines the period, and student and period. No, see, this is wrong. It's student and course that determines the period. All right. Yeah, this actually makes me want to do this as well. Sorry. Because it's not total. Not every student course combination is going to get a period, because not every student takes every course. All right. And then likewise here, not every course is taught in every period. So this actually should have been a pointing arrow. All right. So it's just to show that the things. That's the way it goes sometimes. It can be a little tricky. All right. So again, this right here, this student course period. It's like that. That right there, of course, corresponds to this table here that came out of our normalization. Right. So did anybody just forget all the theory? Because you could go from right here instead. You could have just taken this right here in the beginning and skipped all this diagram making and theory and just kind of used your mind to pound out the table definitions. And like I'm saying, I think most of the time that's what happens in the world, is people do it that way. So so there's that. Okay. So I want to make one last comment, something that comes up. And I don't think there are that many tools out there that help people do it, but this is a very common thing. Let's see, how do I put this? Company X has they've been being boneheaded, and they have a set of spreadsheets. With different E. Some company has a bunch of spreadsheets. They have like some strange. This is happening. This is Excel, and then they have a whole bunch of Visual Basic. Okay, that's been kind of doing things with these things, right? And they don't. I mean, it was just the thing is just a big, a big hodgepodge. And they finally get it in their heads that, oh my God, we need to go to a database. This is getting completely unwieldy. Usually what's unwieldy about it is you got people going in and Smith has a hard time with something. So Smith comes in and he starts hand editing cells. Okay. All right. So when you get something like this, there's a process that happens. And this, I believe actually they do have some automated tools that do this. But sometimes you can write your own to do this. But this is something that will come up. They decide, look, we got to go to a database. I mean, Jesus. I mean, they finally realize this is untenable. But what they do is that, so then they have all this data, and then you got somebody who wants to describe the data, but they don't know it. I mean, no one really knows fully what the data does. So what you do then is you're going to take this, and you're going to go over these sets, looking at all the data, and you're going to be basically saying, all right, you're going to have a program that basically says, is it true that AB determines C? Looking just at the data state that they have, right? Because when you do the translation out to the database, you're going to just write code that's going to go through all the possible combinations of functional dependencies and see whether or not they hold. And sometimes what you have to do, because let's be realistic, what you have to say is, does A, B, D, for instance, determine E? 99.8% of the time. Okay, because most of the time when it's done, when it's at 99.8% of the time, you go back and you ask them, you say, well, look, we think this is the truth. Is this the truth? And they say, yeah, it's the truth. And you say, well, your data doesn't show it. And then they say, oh, yeah, well, that's because that Smith idiot went in and edited the data. So, because Smith got in there and screwed things up, because Smith went behind the whole Visual Basic thing and started just hand editing the data to get the damn thing to work, to kind of put in the data they want to, so they can call it, a day and then he can go home. All right. So, but the thing is that, so you have to have kind of nice algorithms to go through and do this. But anyways, you do that, all that, and then you can transition them from all this data here into something that is going to actually be cleaner. So another aspect of normalization theory is to do this kind of work, where you're trying to kind of figure out how to redefine some kind of nasty situation that developed into a clean database. So, okay. All right. So that was a workshop. I hope maybe that was somewhat useful for people. I mean, it's yeah. I mean, it can go a lot of different directions. I thank people for asking questions in the chat. That was good. And again, I don't know. I guess I'll see when the course gets reviewed whether or not people thought that was useful or just kind of a big waste. I guess I could look and see how many participants have held up fairly well. Not perfectly, but fairly well. Okay, great. All right. So again, this afternoon, it's meet with class. So, okay, I'll see you all.